A standard industrial counterbalance forklift weighs over 10,000 pounds. It carries thousands of pounds of dense material on a protruding fulcrum. This mechanical configuration turns the machine into a massive, highly maneuverable pendulum, where a single miscalculation in speed turns physics into a lethal enemy. To regulate these intense physical forces, the Occupational Safety and Health Administration enforces Standard 1910.178. This is the legal framework designed to govern the science of the lift and protect the operators working in these high-stakes environments. The mechanical baseline of a forklift separates it entirely from a passenger automobile. While a car relies on a front-wheel steering axis to pull the vehicle into a turn, a forklift utilizes rear-wheel steering to push the chassis. Pivoting from the back creates an aggressive, sweeping rear turning radius. The back end of the forklift swings outward in the opposite direction of the turn. Because the rear swings wide while the front pivot point remains relatively tight, the machine requires entirely different spatial awareness. When navigating tight warehouse aisles, passing loaded racks, or approaching blind corners, this steering geometry drastically increases the risk of collision and lateral instability. Preventing workplace fatalities requires operators and safety managers to master the invisible forces acting on the machine. You must understand the physics before the ignition is ever turned. This schematic demonstrates the foundational concept of forklift stability, the three-point suspension system. Even on a four-wheeled counterbalance truck, the steer axle is attached by a single pivot pin in the center. Connecting that rear pivot to the two front wheels forms a geometric boundary known as the stability triangle. Look at the point labeled Vehicle Center of Gravity. The absolute rule of forklift operation is that the center of gravity must remain inside the boundaries of this triangle. When the machine is empty, the heavy rear counterweight pulls that center point back, keeping the system anchored securely. Lifting a physical load adds mass to the front of the vehicle. This shifts the combined center of gravity forward along an invisible line of action. As you approach maximum capacity, the combined center of gravity moves precariously close to the front axle line, connecting points B and C. This shift dictates the vehicle's longitudinal stability. If a load is too heavy, the combined center of gravity crosses over the front axle line. The front wheels become a pivot point, and the rear wheels literally lift off the ground, resulting in a total loss of steering control and an immediate forward tip-over. This diagram illustrates the mechanics of lateral stability on a sloped surface. When traveling over a moderate grade, the vertical line of action drops safely between the wheels. However, if the machine encounters a severe uneven surface, a much steeper grade, or takes a turn too quickly, that line of action leans. Once the combined center of gravity crosses the lateral boundary of the triangle, the machine loses its balance and tips sideways. Gravity and mass dictate that lifting any object inherently degrades the stability of the system. Routine material handling is a calculated physical risk that must be actively managed with every pallet you move. A forklift is a dynamically unstable Class 1 lever. It functions exactly like a seesaw, using the front drive wheels as the central pivot point between the counterweight and the forks. The governing mathematical equation for this lever is the load moment. It calculates stability by multiplying the load's weight by its distance from the fulcrum. If an object slides further down the forks, its distance variable increases. This means its effective weight mathematically multiplies, generating a higher load moment, even though its physical mass remains identical. To account for this geometry, manufacturers rate trucks at a maximum safe load moment using an industry-standard 24-inch load center. This assumes the heaviest part of a uniform pallet is sitting exactly 24 inches from the front face of the forks. Modifying the machine alters this baseline. Adding fork extensions, carpet poles, or barrel clamps permanently increases the distance variable in the equation, pushing the center of gravity further away from the fulcrum. Because the load moment increases with an attachment, OSHA requires employers to update the dashboard data plate. The maximum carrying capacity of the truck must be legally recalculated and reduced to maintain the stability of the system. The forklift's data plate defines the physical threshold of the machine. Exceeding its specifications makes a tip-over mathematically inevitable. Theoretical physics only protects you if the physical machine is intact. The warehouse floor induces immense mechanical wear and tear on these vehicles, degrading their structural integrity over time. OSHA Standard 1910.178, paragraph Q7, mandates visual and operational inspections before every single shift. If the facility operates around the clock, the truck must be verified at the start of each new rotation. This anatomical diagram highlights the initial focus points for your inspection. The forks themselves carry the entire load moment. Operators must visually check the steel from microfractures, physical bends, and excessive wear at the heel, where the metal bears the highest stress. The mast assembly and hydraulic cylinders control the vertical lift. Operators verify chain tension, check for missing stops, and scan for fluid leaks. A drop in hydraulic pressure during a lift causes the mast to drop unexpectedly, immediately destabilizing the vehicle. According to this standardized inspection checklist, industrial tires require strict scrutiny. Because the truck lacks a traditional suspension system, the tires absorb all surface impact. You must check for missing rubber, deep circumference cuts, and bond separation that can cause immediate traction loss on a concrete floor. The legal standard here leaves zero room for interpretation. If a vehicle is found to be defective, in need of repair, or unsafe in any way, it must be removed from service immediately. Failing to lock out and tag out a defective truck instantly voids all safety protocols. Operating a machine with known defects escalates a routine mechanical issue into a willful OSHA violation. Once the machine clears inspection, operators face dynamic hazards in the active work environment. The most unpredictable of these variables is pedestrian traffic. The operator holds strict responsibility for maintaining distance. Standard practice requires a minimum 3 truck-length safe zone from other vehicles. Furthermore, the operator must decelerate and aggressively utilize the horn at all cross aisles, intersections, and blind corners to warn foot traffic. Beyond pedestrians, operators frequently underestimate the extreme danger of traveling with a fully elevated load. When you initiate a turn with a high load, centrifugal force violently pushes the elevated center of gravity outward. It easily crosses the lateral stability line, guaranteeing a tip-over even at extremely low speeds. To counter this, operators follow a strict operational rule. Forks must be carried as low as possible during transit. The load should only be raised to clear ground obstacles, and high tiering must only occur when the truck is completely stopped at the racking. The final major hazard involves operating on grades, ramps, and sloped surfaces greater than 10%. An incline heavily distorts the stability triangle. Navigating an incline requires a specific procedural orientation. The heavy end of the machine must point up the grade. If the forklift is loaded, drive up the ramp forward so the load faces uphill. If the forklift is empty, drive up in reverse so the counterweight faces uphill. Physical space, travel speed, and load height are dynamically linked variables. Altering one without compensating for the others inevitably leads to disaster. There is a pervasive myth across the industry that a forklift certification is a universally transferable wallet-sized card you obtain by sitting in a break room and watching a training video. Under OSHA law, that is entirely false. Standard 1910.178 establishes a strict, non-severable tripartite training model consisting of formal instruction, practical training, and performance evaluation. Online modules, lectures, and written materials fulfill the formal instruction pillar. They teach the physics and the safety rules, but formal theory alone is legally insufficient for certification. The second pillar requires practical training. The operator must physically mount the machine, locate the controls, and practice handling maneuvers under the direct supervision of an experienced trainer. The final and most critical stage is the performance evaluation. A competent evaluator must observe the operator performing actual, unscripted workplace tasks to verify they can handle the physical complexities of the site. Furthermore, these certifications are not universal. They are legally bound to specific truck types and specific workplaces. Moving an operator from a sit-down counterbalance truck to a narrow aisle reach truck demands an entirely new evaluation. Certification serves as legal evidence that an operator successfully demonstrated physical control over a specific vehicle in a specific work environment. Operator certification is an active, conditional status. OSHA requires that each operator undergo a formal reevaluation at least once every 3 years.
However, safety managers must track specific incident triggers that mandate immediate refresher training, completely overriding that 3-year timeline. Any involvement in a workplace accident, a near-miss incident, or a documented unsafe act instantly invalidates an operator's active certification status until they complete targeted retraining. Operator behavior is monitored closely. Engaging in stunt driving, unauthorized racing, or horseplay on heavy machinery provides immediate grounds for willful OSHA citations. If those rules fail and the physics overtake the machine, operators must understand the counterintuitive survival protocol for a tipover. The human instinct to jump clear of the falling machine is almost always fatal, as the heavy overhead guard will trap or crush an escaping operator. The mandate is absolute. Utilize the seatbelt. If the machine goes down, stay entirely inside the rollover protective structure. Grip the steering wheel tightly, brace your feet, and lean away from the point of impact. For HSE professionals, compliance requires a relentless audit of your facility's hands-on evaluation practices. Recognize the immense forces at play in your facility, respect the physical realities of the lift, and ensure every operator is equipped to control them.